The satellites reveal how fire, weather, water, and ice combine to sustain the cycle of life. Everything is interconnected in an ancient and intricate system. But even this is just the beginning of what satellites are discovering. They can analyze and explore how the Earth reacts to external influences. And there's no greater influence than that of our local star, the Sun. As the Earth rotates over 24 hours, the planet responds to the extraordinary power of the Sun. Each day, 170 million gigawatts, over 7,000 times the power that humanity consumes, rains down on the surface, triggering a wave of activity that never ceases. At dawn, plants and plankton begin to photosynthesize, using the light to make sugars and starches, the basis of the food chain. The power source for almost all living things. Sunlight drives wind and weather around the globe. When the air cools at night, it triggers much of the Earth's rainfall. We are part of this circadian pattern too, built to respond to the daily influx of energy from above. The cells in our bodies need sunlight to create vitamins in our skin. Even the flight paths of planes reveal our intimate relationship with the sun. Aircraft travel westwards in the morning to extend the day, and eastwards in the evening to reduce the night. But ironically, the biggest threat to this finely balanced arrangement is from the same thing that allows it to exist in the first place. The energy given off by the sun. The SDO satellite records the ultraviolet radiation released by our star. Charged particles, fractions of atoms, protons, electrons, and neutrons are constantly thrown out, along with massive pulses of electromagnetic radiation. But occasionally, the sun throws out what's known as a coronal mass ejection. This supercomputer visualization shows a cloud of plasma millions of kilometers wide, racing towards the Earth. If these solar particles were free to hit the Earth's surface, they would do serious damage to any living thing, producing fatal mutations in their DNA. Fortunately, the Earth has a defense. An invisible force field called the magnetosphere surrounds our planet, visualized here in unprecedented detail. These images are generated by data from 5 magnetically tuned satellites. Called Themis, the network of spacecraft reveals the force field as it is constantly bombarded by the sun. The shape of the field is produced by the sheer force of the radiation hitting it. A nebulous teardrop 200,000 miles in diameter. As wave upon wave of solar particles strike the magnetosphere, most are deflected. But when a coronal mass ejection arrives, the charged particles peel open the magnetic field's outer layer. The particles are now free to rush in towards the planet. The Earth's inner magnetic field steers the radiation towards the poles, triggering one of nature's most remarkable sights. The Northern and the Southern Lights. And here, we can see the Earth's second layer of defense. Giant ribbons of plasma stream downwards, encircling both the North and South poles. As they strike the upper atmosphere at extreme speed, they excite the molecules of air. The process makes the air molecules glow. The oxygen radiates red and green, the nitrogen blue. Energy that would otherwise mutate all life on Earth is dissipated by the upper atmosphere. In this way, the Earth has shielded itself from the sun's deadly radiation for millions of years. But even this extraordinary apparatus is only one part of how the atmosphere protects life. Down below, there are yet more powerful systems, without which there may be no life at all. The Earth's atmosphere is a delicate resource. A thin blue shell that encapsulates our world. The bombardment of sunlight and heat subjects this slim coating of oxygen and nitrogen gas to incredible stresses and strains. Forces so powerful that if left unchecked, would tear the atmosphere apart. Nighttime from space. The Earth buzzes with lightning. Astronauts in the International Space Station are often amazed at the intensity and frequency of the electrical storms that take place far beneath them. Why does the Earth need these relentless storms? The answer is clear when seen from high above. The Earth's atmosphere is seeking equilibrium. Each day, the combined force of sunlight and vapor creates 40,000 thunderclouds. clouds build up vast stores of electrical charge. Every half hour, 100 megawatts is generated inside an average thundercloud. Enough energy to power the city of Toronto for a minute. To equalize itself, it must transmit the negative energy down to the ground as lightning. But at the same time, it transmits a positive charge upwards into the sky. A vast column of charge rises out of every thundercloud. This invisible force moves at almost the speed of light towards the atmosphere's outer shell. This is the ionosphere, a thin veil of mostly hydrogen and helium gas. Now, for the first time, it's possible to see electric charge interact with this rarefied realm. The ionosphere acts as an electrical conductor. It distributes the charge all around the globe. And we now know that without this global electrical circuit, there may well be no life at all. It's all due to an incredible chemical reaction, which takes place inside thunderclouds as lightning strikes. The electric charge inside the thundercloud grows until it's so strong that the air breaks down into ions. A tiny path forms in which an electrical current can flow. Within 1,000th of a second, a lightning bolt is initiated. It's no thicker than a human thumb, yet 5 times the temperature of the surface of the sun. As it burns through the air, this bolt of energy breaks the nitrogen molecules in the air apart. Oxygen bonds with the nitrogen, creating a substance called nitrate. Approximately 14,000 tons of nitrate is transported around the world in weather every day. It falls to the ground in rain. Nitrate is vital to almost all forms of life. From the photosynthesis of plants to the respiration of more complex organisms, nitrate has driven key chemical reactions in living things for millions of years. Looking at the Earth as satellites do reveals an intricate mechanism that shapes every moment of every day. and drives every beat of every heart on the planet. But there is still one part of this system that's missing. And that is the profound and undeniable effect of a single species of animal, the human race. Looking at the Earth from space has revealed a system of hidden complexity, interwoven at every level. Slow-moving processes connect with others that happen in microseconds. Endless cycles abound. Cycles of death, decay, regeneration, and rebirth. From the relentless power of water and sunlight to the electromagnetic forces at work all around us, every interaction reveals a finely tuned balance.